I'll do you another example. 914, use bond energies from table 9.1 to estimate the enthalpy of formation of gaseous ammonia. Okay, that means that we are going to have to write the formation equation for gaseous ammonia. So the formation equation is arrived at by thinking about what are the elements that make up ammonia. They're nitrogen and hydrogen, and writing an equation to form 1 mole of NH3 from them. Okay? So write down the formation equation on your paper. We've done this so many times now, it shouldn't take you too long. The formation equation for NH3. Okay, what you should have written is 1/2 N2 gas plus 3/2 H2 gas goes to NH3 in the gas. 1 mole of this has 1 mole of nitrogen, 3 moles of hydrogen atoms. That's 3/2 H2, which is the elemental form that hydrogen comes as, and 1/2 N2. Okay, so if you look at this thing, N2, I'll follow my own advice here. We'll write it out in Lewis dot structures. 1/2 N2 plus 3/2 H2 goes to NH3 gas. So the delta H of this formation reaction then will be equal to 1/2 of the bond energy of N2. So that's 1/2. The value we used before was 946 kilojoules, plus 3/2 the bond energy of HH, which is 436, minus 3 times the bond energy of NH, and it's NH single bond, and that's 389, minus 3 times 389. Okay. Everybody understand the numbers that I've just put down in this equation, where they came from and why? So N triple bond N is 946, and H single bond H is 436, and N single bond H is 389 from the table. Okay, if I do the arithmetic, I get minus 40 kilojoules per mole as the delta H of formation of NH3, and this is an estimate. This assumes that all of the delta H comes from bond breaking and forming. There are actually some other terms involved. The actual value, to give you some feeling here for how good this is, the actual value is minus 46 kilojoules. So that's ballpark 10%, plus or minus. Not too bad for an estimate.